here we are, one day further on with the backup camera this time. I've been asked a few times by subscribers to please explain a bit more on the indexers, and now I have a spare. I've been game enough to knock the assembly pin out of one, and I can put together a bit of a show for you. I'm not going to send dimension drawings, but I will give you dimensions as we go along and you can write them down. It is really a very, very simple affair, and something I don't think you'll have a lot of trouble picking up. So I'll zoom the cameras in for a closer look and bring you back then. Okay fellas, I hope the heck I don't knock the focus out too much. We'll do the body shape first. 20mm that way, by 17mm that way. The slot is 12mm. By 12.7 or ½ inch deep. Overall length 22mm, including the curved part at the end. There is a cross pin that holds the assembly together. It's 3mm diameter. It's 4.5 in from the edge, 8.5 in from the end. 3mm, and there's a countersink on one side, about 1.5mm on edge. Why the hell I don't know. It's just been pinned over into the countersink on one side. It doesn't make a lot of sense. Now there is a hole in the back end, which is spring diameter 6mm by about 3 deep, and that's what holds the end of the spring. So a fairly reasonable assembly. The shank on it is 16mm diameter by 55 long. So there's nothing really difficult in machining that up. Now the actual indexing finger, which originally have been 12mm square, looks a little bit complex, but I don't think there's too many parts to it. It has a rounded end. That whole end is 23.3 long. Distance to the pivot 13.7. Length in this next section 16.18. Overall length from there to the end of the finger 43. And the spring, as I said, is 6mm diameter. The free length out of the hole is 10mm. I think that should just about do it. Quite obviously this goes with that at Suzanne. There's only one way it can go. Handle pin. Like it's a tap fit. Okay, so I hope that gives you a little bit of an idea of what's involved in it. Look, you don't have to stick to those dimensions. You can build it with whatever you got for scrap. One thing I did forget is there's a screw that holds the blade to the body, and the blade is only, well, measure it for you, 3mm stick. So it's a 3mm piece of plate. Overall length at 35mm. So that should be enough for you to build it. This type of indexer I find to be really good with the spring-loaded arm. You can easily go over a cutting edge and just click back in, and it makes it easy for you to use. Okay, we'll get back on with the main video in a few minutes. G'day again guys, just now the following day, and here with a few more words for you. I made the comment when we were looking at that form relief grinding attachment that I didn't know what the hell 30mm collets would do. Well, I found out. I just scrummaging around here, and I remembered I was given a large number of cutters like this. I don't know what the hell they're for, but they're 30mm and 25mm. There's this brazed carbide dovetail cutter and other various dovetail cutters from 15 degrees to 45, all with either a 25 or a 30mm shank. So all that I can think of is something like a Cincinnati Hydra Talbot out of Europe, and they were for leading dies or something like that. Some have been made from high-speed steel. One's been made of an old auto lock cutter, thread lock cutter. And some of it's good work, some of it's pretty bloody ordinary. But I honestly don't know what the intention was, whether it's for a copy mill or whatever, doesn't matter. I've got over a bit of procrastination around the shop, and the best way is just to get amongst it. I've taken the dividing heads out from the pallet up against that wall and got them underneath the shelving. That gives me quite a lot of space. I'm preparing for the two machines that are coming in. And besides the shaper here, I've got an area that's in total about 3.5 metres by 6.5 to fit 4 machines into. So I think I'll manage that quite well, but actual placing I'm still up in the air, and it's a pretty hard decision to make because once all the equipment's taken away, they're bloody heavy to move around again on your own. I can do it, but it's just not that easy. And during the move, my little homemade load skates were moving just a couple of 100 kilos, but the big dividing head with all the accessories is bloody heavy, and yes, they were worth making. So I'll zoom you around now. I'm going to dismount a little bit of gear off the tool and cutter grinder, dress the wheel and try and set up the little cheap spindexer to see if I can't get that zero angle drill ground. So that'll be a bit of experimentation, and if I get it to work, I'll bring you back in then. I've been practicing a little bit. First I chamfered the side of the wheel using my DS1 dressing stick. You can see all the abrasive dust as a result. I then dressed the face of the wheel, and I'm quite surprised at just how sharp this wheel is acting. It's just a standard Flexifit 38A60, and it's taking the point of the drill back very, very fast. I had to reposition the drill sideways a little. I don't think I was taking enough of the point off, but we'll move in just a few thou at a time. The actual execution with the spin indexer is much easier than I thought. I thought I'd be like a bloody octopus trying to get this done, but it's working really well. I'll put the safety specs back on, crank the machine up and wind it in a few more thou. And then I might just back out a bit so you can see the action of the spin indexer a little bit better. Okay. Now I've got the spin indexer locked into 0. Okay, disconnect the indexer. Go around to 30 degrees and wind it back out again. Take the pin out. And it's around 180. Wind it in again. Yep, that's looking pretty good. Okay, we'll go back to the 180 degree point. That's it. I'll take a few more out. Like that. Take it around to 0. Wind it in again. There we are. Take the pearl out. Okay, let's see what we've got. We still haven't formed the drill fully, but I'm reasonably happy with the way it's performing. Okay, we'll see if we can't get camera 2 back a little bit. Or camera 2, it takes the away shot. Okay, with the spindexer, what I'm doing, you can see the graduated scale reasonably well. If the spotlight would just stop shaking. Okay, first I'm plunging in with the spindexer set to 0. Now I don't know whether 30 degrees is correct or it should be 45. I think I was doing 45, but we're still experimenting a bit here. So with the pin selected in 0, I'll wind it in until where I was, which is about there. Then as I'm getting fairly close, I'll crank it in about another 3 thou, and I'm just at the point where I think it might start to chatter, purely by the sound is coming off the drill. So I won't be doing more than a couple of thou at a time. Once I do the plunge to set the point angle at what I want, I then, and I better rotate out from this so I don't put any force on the wheel, I rotate around to the 3 position, which is 30 degrees, then lock it, and then I can back the drill out, rotate around quite simply to the 180 mark, plunge in to form the centre, pull the pin out again, rotate around until the 21% position, and then I should have formed the point. So I'll give it a bit more of a try a few more degrees, and then I'll dissect the drill and see whether it's been ground sufficient or not. Okay, bit more noise and away we go. Just rotate it around. Around the 180. Okay, and back it out. And as they say on TV, now we'll go for a commercial break and see what I've done. Okay guys, it's become apparent to me a bit about what's happening. That's something that I hadn't expected. That'd be about right. As I'm rotating the drill around, there seems to be a bit of a dead point on the end. It's as if I've overground something or crashed the drill, and what I've come across is the remains of the split pointing done in the factory. So I'll have to do a fair bit more grinding to remove that. I may have to go down about another 1/10 hour or so. That won't change the shape of the result, but what I'll do is I'll initially do that at 30 degrees rotation and then increase the amount of rotation as required. Okay, that could take some time because there's a lot of engagement with the drill, so I'll bring you back when that's ready. Okay, welcome back guys. I did a little bit of changing and experimenting today, and I think I'm getting fairly close. One thing that put me off was the previous grind. It was a split point drill, and I was looking at what they put in as the split grind, and I'm quite surprised how far I have to go to get the clearance required behind the cutting point. And I can't put too much of a finger in there or I'll lose focus, but there's the drill at 0. I'm going by the angle on the spindex, and I'm actually going around to 75 degrees to get sufficient clearance behind the pilot, which is more than expected. I tried at 30, 45, 60 and the point still didn't look right, but now at 75 degrees it's starting to look like what I would expect. All we can do now is take it over to the mill and give it a bit of a try and see if it drills okay. Maybe 90 degrees is where I have to go, but I want to do this gradually so I don't overshoot the mark. Also, I'd like to point out I had to redress the wheel. It had become fairly glazed, although it did cut very, very quickly in the beginning. But one problem I have here, the whole setup is fairly cantilevered back from the table, and the table is very small and not sufficient for this sort of jobs. I'm starting to get a lot of chatter, and I'm reluctant to keep engaging more and more on a bigger and bigger grinding area on the workpiece, just in case something goes bang. But anyway, I'll back it out, take it out of the collet chuck, and we'll give it a try on the mill. Bye for now. G'day guys, back at it again. Here we are at the mill. I've just put the first hole through with the just ground 0 angle drill. It does take quite a bit of feed pressure, so I haven't got the point exactly right, but it's a nice clean hole. It overlapped with the other hole just a little bit. Maybe I better stop gas bagging when the camera's around and make it a bit small if you can decide for yourself. I still think I may regrind it a bit further around the point, but I'm getting told by the Director of Affairs I've got to get back to the house, so I'll do one hole for you, see what it's like, and then get the video up for all to see. I did get a little bit aggressive with it with the last hole, and all I got out of that was a lot of squawking from the drill bit as it jammed up and slipped in the chuck. But let's see how it goes this time. As I said, it's a bit slow to penetrate. I haven't got the point 100% right. Okay, I think you can see that that's a reasonably clean hole. It's stitch drilled, overlapped into the previous hole by a bit. You can go a lot further, but I'm redoing this after 25 or 30 years, so it's a long time between visits. I don't know, this is a bit of a funny roll plate, but after I got down about 2 or 3 mils, it just started to drill quite freely. Maybe a bit of my crappy ground point broke off, I don't know. But as a special purpose drill, good for general workshop drilling. If you don't mind having a second set grounded the system, well, that's good as well. If you've got any questions whatsoever, throw them up in the comments. I'm free to answer anything, and I'm also open to suggestions on how to improve it. I will at a later date try and put more and more body clearance in it, but as I said, I'll start to get a little bit of chatter with that wheel. Might experiment a bit more grinding by hand. Anyway, if you like what we've seen today, please like and subscribe, and I'll catch you all in the next video. Okay fellas, as promised earlier, sorry, forgot the last bit of this instalment. A very simple way to check your drills once they're ground. I'm always looking for something to get it accurate without having to use instruments, and this was suggested by Jack Dyson. The original gauge was a piece of 1 by 1/8 flat, in this case 25 by 3 or whatever, and I bent the end up and welded a second piece in there with a V in that. So this is a simulated demonstration. Mike's cross-drilling jig will do, but it's merely a case of scribe a line on the flat with one edge of the drill, turn it 180 degrees, scribe a line with the other edge, and if they don't coincide, you know which one's out and by how much. Nothing could be easier than that. The other gauges sort of work, but when you get down to 1 thou accuracy with the Stone Age instrument, it's a bit of a no-brainer. And then here comes the other interesting part. How do you tell if the drill point is on centre? And that's always a very difficult thing to ascertain down to the last ferry's fart. Well, in the end of the piece of plate, and I'm sorry I'm doing this left-handed so it'll be a bit difficult, a great big Boilermaker's wallop with the centre punch. Put the centre of the drill in the centre punch mark and just run up a gauging block next to it. See which edge touches the block and by how much the other one misses. Now that could not be easier. Dead simple. Good old Jack thought of that. I lost mine, or someone else helped himself to it, I don't know. But yeah, 1 by 1/8 strap, you need at least 200 long, or however long the drills are that you want to check. And I do say this, that it is better if you have a greater height than this, like up about 25 mil. So it gives you a bit more of an angle for the edge to scribe at, but it just works such a treat and it's so damn accurate. Okay, bye for now, I'll get off the line at last.